2007. He's a professor of horticulture, and he works specifically on Malladi, which is this science of fruit growth. He's also on my committee, so many things in here. So without further ado, I hope we have a great talk. It is very nice to see you. I will have a fruitful discussion later, and it will be just teaching. So thank you.
Right. Thanks, Carmen, for inviting me here. This is my first time attending this Science Cafe, and I'm really impressed to see a pretty good turnout here. As Carmen mentioned, I work with fruits. It's a little more than a passion for me. It's an obsession at some point. But I work with a variety of different fruit crops. I work with apples, I work with peaches, I work a lot with blueberries as well. And in the past I've worked with citrus fruits. And I have an interest in a host of other kinds of fruits as well, a lot of which are not really grown so much in the United States. I'm originally from India, where we have a whole lot of other subtropical and tropical fruits. So that's probably where the passion for fruits really kicked off. What I'll try to do today is try to give you a little bit of an introduction to fruits and how it is that fruits grow. And along the way, I'll also try to introduce you to some of the research that we are doing in my lab as well as in Carmen's lab at the University of Georgia. So it's fruits of their labor, how do plants grow fruit? Again, it's a pun, and Carmen is the one that you need to hold responsible for that. So a lot of us do consume fruits quite a bit. In fact, there is always, over the last decade or so, there's been an increasing trend in terms of food consumption. A lot of that has to do with this idea that fruits are very rich in a variety of different phytonutrients. And that has kind of been, especially for certain fruit crops, like for example with blueberries, that's been really one of the big drivers of increased production and consumption for fruits over the last decade or 15 years. But it's not something that's exclusive to what we're often referred to as superfoods. It's a general aspect with many fruits. They're really plentiful in terms of a variety of different phytonutrients. Sometimes it's antioxidants, sometimes it's other kinds of compounds, polyphenols, and flavonoids, all different kinds of compounds. And often fruits tend to be very concentrated, okay? And that tends to be one of the big reasons why we consume them. And a lot of that, there's a lot of research that has gone into this in terms of trying to understand the health benefits of food consumption. And one of the things that has often come out of this is that you can always go and try to pick out those individual compounds that are really beneficial, or maybe beneficial for human health. But when you consume the fruit themselves, you actually get this sort of an additive, and sometimes even a synergistic effect. And that's kind of one of the reasons why consuming the fruit directly itself is a lot more advantageous than trying to get those individual compounds out of the fruit and trying to take those pills. Okay, and that's a common theme that's actually come out of a variety of different studies. And this slide is a little bit misleading because what it shows is that we on a per capita basis we do consume a lot of fruits, but as it turns out, if you take a look at some of the CDC websites, there is actually quite a bit of a gap there. There's a lot of people who don't really consume many fruits or even vegetables for that matter in terms of their diet. So there's always room in terms of increasing or improving your food consumption. The thing though that you have to keep in mind is that plants do make fruits, and these fruits do contain all these valuable different compounds that are present. The plant is really not doing it for our benefit, right? It's not really producing all these compounds and putting them into packaging them really nicely in a really colorful way into these really tiny organs for human benefit. What it's really doing is something really different. What do you think? Why do you think plants make fruits? Big reason. Seeds. There you go. That's the big reason why fruits are produced. Inside of those fruit is where you have the seeds, and for the most part, the seeds need to be protected as they're developing. They need a house that they can stay in, and they need to be provided with the nutrients so that they can actually continue their growth. And once they actually are mature, they need to be dispersed. They need to be moved away from the mother. And that's where the packaging comes in. If you have a nice, attractive package with a lot of these compounds and flavor that's associated, that helps to disperse it. And all along the way, though, those compounds are often helping in terms of protection. They're actually providing that security to those seeds. Often these compounds have some kind of a protective function, some kind of a defensive function, and very often they are trying to deter other kinds of predators from consuming those foods before those seeds are actually ready for dispersal itself. Okay, so that's kind of an important thing to keep in mind. We do enjoy those fruits, but the plants are not really making them for our consumption. It's to house those seeds. Some of you may be very familiar with this. This is a simple diagram of a flower. You probably have seen these at some point in your education. And this is surprising, though, that sometimes I put up this slide and ask students in my class, in my introduction to fruit crops class, to explain where the fruit comes from, and very often I draw quite a few blanks. The point to keep in mind is that this flower that you see is the one that is eventually going to develop into the fruit. Okay, you're going to have pollen landing onto this stigmatic surface. And once that happens, you have the pollen tube germinating, assuming that we have a compatible interaction. That pollen tube is going to go down the tube, something that's referred to as the style. It's going to go down the ovary. Once it reaches the ovary, then you have what is referred to as a double fertilization event, where you have two fertilizations that are taking place, and that's what results in the formation of the zygote, and then ultimately something called as an endosperm tissue, but ultimately what you get from that is the seed itself. Okay? And once that happens, very often there is some kind of a signal that is sent from those seeds. And that signal kind of diffuses to the tissue that is surrounding the seed itself. And those signals are what start promoting the growth of that surrounding tissue. And that surrounding tissue then, which is basically the ovary wall itself, is what develops ultimately into the fruit. So now you have the ovary there, and different parts of the ovary are then eventually going to form the different parts of the fruit itself. The outermost part, layer of cells or a group of cells of the ovary wall, that's going to give rise to the exocarp, or this pea tissue that we often think about. Most of the bulk of the ovary wall tissue gives rise to what is referred to as a mesocarp, which is often the fleshy tissue that we consume. So what you're looking at is a peach. So really the bulk of what we eat in a peach fruit is really this fleshy mesocarp tissue. Okay? And then you have this innermost layer of cells of the ovary wall. That gives rise to typically what is referred to as an endocarp. And in case of peach right here, that kind of undergoes a lot of modifications. It actually becomes lignified, the cell walls start actually becoming thicker and thicker and harder, eventually to a point where you start developing this really hardened endocarp tissue, and that is what we often refer to as a pit, right? And the pit itself, many people often think of it as just a seed, but really inside of the pit is where you really have the seed. The pit itself is still part of the fruit, something that we don't really consume, but it's still part of the fruit itself. Okay, so this is something that is often referred to as a true fruit. Okay, and so this is where the fruit is actually coming from, the ovary itself, and the different parts of the fruit are originating from the different layers of the ovary wall itself. Now, as it turns out, though, there is a lot of diversity in this process. It's not always really that straightforward. There's a lot of modifications that can take place. In fact, the previous picture in the case of peach in itself is quite a modification. That kind of a fruit is something that's referred to as a drupe. And in case of a drupe, you actually have that characteristic hardening of that endocarp tissue and the formation of a pit. So when you think about your stone fruits, your peaches, your almonds, your apricots, plums, cherries, all these are what are referred to as stone fruits. All those have that characteristic nature. They're all drupes. They have that hardening of that endocarp tissue. Okay. One of the simplest types of fruit is something that's referred to as a berry, and tomato is a very good example of a berry fruit. Okay. Some of you may not even, Carmen was just mentioning it just a little while back. Some of you may not realize that tomato is actually a fruit. Tomato is botanically a true fruit. It's actually derived from the ovary, It houses the seeds, and it has the basic structure of basic and anatomical structure of a berry fruit. Okay. What may be even more surprising is that you can have a variety of other organs which we may not realize immediately as fruits, and this is kind of where things like eggplants might come in, or cucumbers, or squash, or zucchini. All these botanically are fruits as well. And they have a pericarp tissue, they have a peel, they have fleshy mesocarp in most of those cases, and inside of it is where they are housing these seeds. That's kind of that's their main function. But as I said, there are quite a few variations to this sort of a central true fruit theme. You can have, in some cases, other tissues that are associated with the flower, but not really part of the ovary itself, that can develop into the fruit. And that's when you often refer to them as accessory fruits. These are coming from floral parts which are not the ovary itself. And these floral parts can be very diverse. Sometimes it can be the stalk that is housing the flower itself, or sometimes it's tissue that is surrounding that ovary. And you can have these tissues that pick up the signals that are coming from the seed and then start developing into the fruit itself. So a little bit of show and tell here. Many of you, I hope, have seen a strawberry before, right? So this is a really nice example where you can take a fruit like this and put it in like 3 different categories. First of all, does anyone know what part of this is a true fruit? Not you don't talk. You know this. Does anyone know which part of it is a true fruit? These tiny dotted seed-like structures that you see on the surface of the strawberry fruit, those are your true fruits. That is what is often referred to as an achene. It's a type of a dry fruit. So what happens in this context is that you have a tiny seed, and on the surface of the tiny seed is where you have all those 3 tissues, your exocarp, mesocarp, and endocarp tissues. All those are really thin layered and surrounding that tiny seed, and each of those is actually a tiny fruit. Okay? And then all this fleshy part that we really love to consume is really not coming from the ovary itself. It is what is the tissue that gives rise to this is something that's referred to as a receptacle. Okay, so it's, if you kind of go back one slide, see the base of the flower there, right below where the floral organs are, that bulbous structure. That is what a receptacle is. So that is what is going to give rise to this fleshy part of the fruit. Okay. On top of that, you can have sometimes not just a single fruit that is formed. What we rather have is an aggregation of fruits. So that's kind of what a strawberry is, because you have all these tiny fruitlets that are present on the surface, right? But it's not just a single fruit. So this is what is referred to as an aggregate fruit, because you have one flower which had multiple pistils, multiple female organs that were present, each of which ended up making a tiny fruitlet. So all of those come together to form an aggregate fruit. So strawberry now is an aggregate fruit. Okay, it's a false fruit or an accessory fruit because all this fleshy stuff is not really coming from the ovary. It's in other parts of the flower, and it's also an achene because the true fruit right there is actually this tiny little dot, which is a dry fruit that is referred to as an achene. So strawberry is kind of pretty unique that way. Okay, but it's not the only one. There's quite a few other fruits that are often called false fruits or accessory fruits. Apple, a fruit crop that I work with, is a very good example of that. In case of apple, it's still quite debated as to what the big fleshy part that we consume is. So this is kind of a section of apple. Mark was an undergrad worker in my lab, and I made him cut about like 1,000 fruits and take pictures of these. But this is kind of what most people like to consume in case of an apple fruit, the outer fleshy portion of it. And yeah, in reality, it's not really the ovary. The ovary is really present right around where the seeds themselves are located. Okay, there's this small amount of fleshy tissue that is present right around where the seeds are present. That is where the true fruit is. That is where the ovarian wall is. And all this tissue that is surrounding that is really coming from either what is referred to as a floral tube, this tube-like structure that was present around the ovary, or it was coming from the receptacle. It's something that we have still not resolved in all these years. It's something that was postulated 150 years ago, and we're still debating as to where that tissue really comes from. Some people argue that when you eat an apple, you're really eating a stem, because that part of the stuff is really, it's coming from stem-like structure, what would correspond to a stem within other parts of the plant. Okay, so really, apple is again an accessory fruit. Again, it can be classified as a pome, because the type of fruit that is produced inside is what is referred to as a pome. And some people would also argue that because it has this tiny cartilaginous tissue right around where the seeds are present, it could also be called as a fruit, because that's what fruits are. The endocarp is kind of a little bit harder. Okay, so in any case, that's kind of the sort of variation that you would normally see with fruit crops. There's a tremendous amount of that. In my lab, what we work with a lot is in terms of understanding how it is that fruits grow, and how it is that fruits develop, and how it is that they get to their final size. And this is again a very diverse process. This is not something that you can really learn about in one type of a fruit and simply apply to all the rest of fruits. There's a lot of diversity in how it is that fruits grow and how it is that fruits develop. And in some cases, it's also a way that I justify myself that I'm working with a crop that takes up to a decade sometimes to actually start making fruits. Okay, you have to be really patient when you're trying to work with these things. It's kind of important to understand though why it is that fruit growth is important. Fruit growth is what ultimately determines what the final size of the fruit is going to be. And that is important because this is one of the parameters which determines the yield of fruits. So if you're a grower, if you're trying to produce fruits, there are really two things that you're trying to maximize in terms of your yield. You're trying to increase the number of fruits that you can produce, and you're trying to increase the size of those individual fruit, because the product of these two is going to really determine what that ultimate yield is going to be. Okay? And as it turns out, a lot of people put emphasis on size. So if you are a consumer and you go to a grocery store, it's more likely that you'll pick up a larger sized apple than a really small one sitting right next to this apple. Okay, and that is pretty common. Consumers seem to have that sort of a preference for larger sized fruits. Okay, and what this also means then is that growers put a lot of emphasis on it, because what they can do is that they can produce these larger sized fruit and start charging a premium for that, start increasing the price of those things. Okay, and that's kind of how they can profit more from producing these larger fruits. Now, what they do is in terms of food production in the field, they often do perform a variety of different things, different practices to maximize that fruit size potential. They try to sometimes minimize the number of fruits that are present on a tree, because if you have too many mouths to feed, each one of them is going to be get a small portion of the resources, right? So if you kind of reduce those number of mouths, then you can distribute those resources much better, and each one of them can actually get a larger share and can get to its maximum potential. Okay, so that's the logic behind it. And then they do other things as well. They might apply certain growth regulators, which will increase the size of the fruit, or they can sometimes fertilize a little more, which is not always a great thing, but that sometimes can help in terms of improving the size as well. But in any case, that's their goal, to try and improve that fruit size characteristic. And in order to do that, we need to understand how it is that fruits grow. So in our lab, the goal is to get from a small size fruit to a larger one, or to optimize fruit size. And the logic that we have taken is that if you understand how it is that fruits grow, you'll be able to optimize this particular process. A thing that I mentioned a little while back is that not all fruits are the same, and you can look at all these different kinds of fruits, and it's not always that the fruit growth patterns are going to be exactly the same across all these different kinds of fruits. If you take a simple example of tomato and apple, these are two very different systems. Tomato is typically cultivated as an annual system. You plant the seeds, you let the plant grow, and then the fruits are formed, you harvest the fruit, you're done with it, and you move on. Apples are not like that. If you start from seed, you definitely have to wait about 8 to 10 years before you can actually get any fruit from them. Okay, so you typically start off with a cutting or a grafted plant. You put it in, you let it grow. Maybe after 4 years or so, it will start making some fruits, and then it will start actually progressing. And over its life cycle, it's going to keep continuing that fruit production process. Another thing that is different with these perennial fruit systems, like apple, is that the buds that make the fruit are actually produced in the previous season. Okay, so what that means is that the fruits that you will buy this year or you might harvest from apples this year were actually started last year. They were started last summer, in fact. Okay, the flower buds were formed last summer. They kind of grew. They went through some developmental process. Then they went dormant during the winter time. They came back from dormancy. They picked up, and then they started growing again. And then they got fertilized, and then started making a fruit. And then you have the fruits ready at the end of the season. Okay, so it's a really multi-year process when it comes to perennial fruit systems. If you're talking about their growth. But even if you think about how it is that fruits grow from the time of the flower buds opening, there is still a lot that is going on. There is something that we refer to as a pre-bloom process, where the buds open up and they kind of go through a little bit of developmental process up to the point where the flowers open up, and then you have something that's referred to as fruit set. This is kind of where the pollination and fertilization events take place. The seed gets formed. You have signals coming from those seeds. Eventually, the fruit starts developing in size. So that's kind of where the fruit set is taking place. And then you actually have the fruit growth process itself. And this is kind of, the different phases. There's an early period of this process, and then there's a later period of this process as well. And then finally you get to the point where the fruit is becoming mature, and that's kind of when other metabolic changes kick in. That's when, you have all these changes in color, changes in flavor, changes in texture. All those start taking place towards the end of that development process. Okay. Our focus has been to try and understand how it is that fruit growth takes place through all these different phases of development. And in reality, there's probably two main ways in which any given organ can increase in size. One way is to have a lot of cell division. Okay, so you can start off with a single cell, and that cell divides, makes 2 cells, another set of division each for each of those cells. You have 4, and then you have that sort of an exponential increase. Okay, and that can lead to more and more cells being formed, and eventually you can get to a large number of cells. Now these cells simply don't form, don't start dividing. As soon as they have a new cell is born, it's not simply going to start dividing and producing another cell. If it did that, then what will happen is that that individual cell volume is going to keep becoming lower and lower. What typically happens is that you have a cell that's formed, it doubles in volume, then divides in half. Okay, and then those individual cells double in volume again, and then they divide. So that's kind of how you can have that increase in cell number that is taking place, and that can help in terms of increasing the size of the organ, right? That's one way of increasing the size of fruits. Another process that can also lead to this increase in size is the expansion of those cells. So if we have those individual cells, but the cells simply keep increasing in their volume, taking in more and more water often, and putting it into what are referred to as their vacuoles. If they do that, they can keep increasing in terms of their volume itself, and that can also help in terms of improving the size of that organ. As it turns out, invariably across all kinds of food systems, these are really the two main processes that drive growth. And very often, cell division is the first process that takes place, and this is where you start off with a few number of cells, and you have multiple rounds of that cell division taking place, and then you have a whole bunch of cells that are formed, and eventually those cells undergo post-mitotic cell expansion. So each of those cells keeps expanding in size, and then you get to that final volume of the food itself. Okay, and that's a common theme across pretty much all kinds of fruits. Now, the extent of that may differ, and the timing of that might differ. Some fruits might do a lot of that even before the flower is completely open. Okay. Some of them do a little bit before the flowers open, and then do a lot more after the flowers have opened, after fertilization has taken place. And that's kind of when they make more and more of those cells. That's kind of what happens with apples. They start off with a few cells. After the fertilization takes place, after fruit set occurs, they divide a lot, they change their cell number by 4 or 5 times, and then they don't divide it as much anymore, and each of those cells actually starts increasing in volume, and then you actually start getting this really massive growth. Really, the majority of that growth is brought about by that increase in the cell volume itself. In tomatoes, for example, cell volumes can increase about 10,000 times, 20,000 times. That's the kind of size difference that you're really talking about. Okay? You can have massive cells to the point where with very little magnification, you can actually see those cells itself. That's the kind of change in volume that can take place simply by cell expansion. In any case, these are the two main processes that drive growth. The cell division and cell expansion, these are going on during different time periods. There's a little bit of cell division that occurs pre-bloom, kind of stops a little bit after that, kind of waiting for fertilization and that fruit set to take place, and then picks it up again after that fertilization event, and then you have a period of very rapid cell division taking place, and then you actually have cell expansion that is happening. Okay, so one of the approaches that we have taken in my lab is to try and understand how it is that these two processes, cell division and cell expansion, are regulated during these different time periods of development itself. And we are looking at some of the main factors, some of the main regulatory processes that are controlling them. And what we think are important are these three that are put in a blue box up there. Hormones, phytohormones, plant hormones that are really critical in terms of regulating a variety of different processes that go on within plants, but are also really important in terms of fruit growth and development. That we think is one set of key factors that regulate cell production and expansion during fruit development. Another set is simply the developmental process itself. This is kind of where a lot of the genetics comes in. A variety of different genes regulate how it is that cell division takes place, how it is that cell expansion occurs, and how many rounds of cell division can take place, or how extensive that cell expansion can be, and all those kind of play into how that organ size is controlled. And then ultimately, resources in terms of carbon or nitrogen. That's what C and N stand for. Really, some of the major nutrients that are going into the fruit. Okay, you have to kind of keep in mind that the fruits are they may be green, they may be photosynthesizing a little bit, but for the most part, they're still dependent on the rest of the plant to provide them with all these resources. Okay, they can fix a little bit of carbon, CO2. They can take it in and they can actually make some sugars of their own. But the bulk of the sugars that end up in your fruit, they're actually coming from the leaves. The leaves are the ones which are doing their job, and then they're just transporting it in and putting it into dumping it literally into the fruit itself. Okay. So how much of those resources make it into the fruit, and how effective the fruits are in terms of putting those resources, that has a very strong impact on how it is that fruits grow. Okay. So what we try and do is, on different levels, on physiological levels and molecular levels and so on, we try to investigate how it is that cell division and cell expansion are regulated during these different stages of growth and development, and how it is that these different factors, phytohormones, developmental signals, and resource availability, how it is that they are actually controlling these two processes of cell division and expansion. Okay, so that was my really quick introduction to fruit crops and how it is that fruits grow. And I'm happy to take questions, but Carmen mentioned that typically we take a break here and then follow up with questions. So